Alright, let's go back to the ice cream sample. Let's say we ask people about strawberry. And 25 out of 100 prefer strawberry as children, and adults had 40 out of 200 who picked strawberry. So, our population is children and adults. Parameter. P equals proportion of children who prefer strawberry. And of course, I need to go back and put this down as P of C. And P of A is proportion of adults who prefer strawberry. SRS is stated. Independence. 100 times 10 equals 1,000, which is less than the total amount of children. And 200 times 10 equals 2,000, which is clearly less than the total amount of adults. And so, we now have to go to the normality. So over here, I'm going to have P total, because I've already used PC for, which I would normally use for pre-combined. And we got 65 out of 300. Because 65 like strawberry out of the 300 total students, that turns out to be 0.217. So 100 times 0.217, 100 times 1 minus 0.217, 200 times, and I realize that it seems silly to do the bigger number because you know these are going to be higher than the smaller numbers, but we need to basically show that all of them are bigger than 10. So let me take those off because we need the numbers. So this is 21.7, 78.3, 43.4, and 156.6, which are all bigger than 10. All right. So here we have the normal curve. Where PA is equal to PC, and sigma is equal to, so really I should do this as PA minus PC. Which one do we use first? PC minus PA equals 0, and S is equal to 0.217 times 1 minus 0.217 over 100 plus 0.217 1 minus 0.217 over 200. And so we got 0.05 as our answer for the approximate standard deviation. And when we come back here, we see 25 out of 100, which is 0.25, and 40 out of 200, which is 0.2. So 0.25 for the children minus 0.2 equals 0.05, so we're pretty much almost one standard deviation away, and in the positive direction. So p hat c minus p hat a equaled 0.5. Now, looking back, we forgot to do the actual hypothesis test, so let's put that in now because we need this back at the beginning. So my initial hypothesis is that the P of A is equal to the P of C, and because we're not sure which one would have had more at the beginning of this, we're going to make this a two-sided. So I am going to shade over here, and I'm going to shade over here. So Z equals, that should be 0.05 as well, 0.05 minus 0 divided by 0.05, which equals 1. Probability Z is greater than 1, or Z is less than negative 1, is 0.317 after I multiply it by 2, which is bigger than 0.05. Alpha equals 0.05. See, it's good to be able to go back and put that stuff in. I fail to reject the null hypothesis. I do not have evidence to suggest that adults and children have different proportions favoring strawberry. So sorry about having to go back to the beginning to fill in the hypothesis, but it's all in here.